Alright, so today we're going to talk a little bit about binomial expansion. And remember, a binomial is simply an expression like this. And I'm going to call it a plus b, and I'm going to use a plus b. And this is a plus b to the 1 power, which is simply a plus b. And we know from all our practice, when we square a binomial, we get a trinomial. And if we cube a binomial, well, we know the n2 are going to be a cubed and b cubed, but I also know relatively quickly that the middle two terms are 3a squared b plus 3ab squared. And I also can quickly do a plus b to the fourth, which is a to the fourth, plus 4a cubed b, plus 6a squared b squared, plus 4ab cubed, plus b to the fourth. Now, I can keep going, but you have to realize that there's some trick here, or something that is occurring that allows me to do binomial expansion so quickly. And what I'll jump to is that we can't be lost that the first thing, which we skipped, was what's a plus b to the 0? Well, it's 1, and you see here I've filled in the 1 at the top, and I've also filled in all the 1s on the sides and underlined all the coefficients. So, if we see this pattern, and now I'm going to shrink down and rewrite the numbers. There's the 1 at the top, a plus b is 1 and 1, 1a squared plus 2ab plus 1b squared, 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed, and then finally 1a to the fourth plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus 1b to the fourth. And we notice a triangle is forming here. And we also should notice the pattern here. Now, I would love to take credit for this, but this was discovered long ago by a mathematician named Pascal. And we call this Pascal's triangle. And it is a nice trick or a method for doing binomial expansion. So let's do an example. Let's try a big one, like a plus b to the 7th power. We'll go to a new slide. And I can write a plus b to the 7th power. Now, we know that we can then start writing the triangle. A plus b to the 0 is 1. A plus b to the 1 power is 1, 1. And I can start going. Here's the order 2, order 3, order 4, order 5, order 6, and finally order 7. 1, 7, 21, 35, 35, 21, 7, and 1. And those will be the coefficients of the whole binomial expansion. So if I make this a little smaller so we can write it, and I pull this up, I can now write the expansion using coefficients. And we realize a plus b to the 7th power, every term has to have an order of 7. So I have 1, a to the 7th, plus, and that would be b to the 0, but we won't write it, plus 7, which is the second term, a6b, which is still order 7 for the term, plus 21, a5, b squared, plus 35, a to the 4th, b cubed. And I'm going to go to the next line, plus 35, a cubed, b to the 4th, plus 21, a squared, b to the 5th, plus 7, ab6, plus 1b to the 7th. And I have just expanded a plus b to the 7th without writing it all out. But it's awfully rare to have that type of problem. So we really have to try something a little more difficult. To make the problem a little easier, we will not go with such a high order. But let's do 2x minus 3y, and we'll go to the 4th power. And again, this is a binomial. And again, I will start writing Pascal's triangle. A plus b to the 0 is 1. A plus b to the 1 power to the 2 to the 3, and finally to the 4th power. Problem here is I don't have a plus b. I have 2x minus 3y. So the first thing I'm going to do is I'm going to set a equal to 2x, and I'm going to set b equal to negative 3y. And by doing substitution, I can rewrite the binomial above as a plus b to the 4th, which I now know expands to 1a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed. And I'm going to run out of room, so I'm just going to go down a line, plus b to the 4th. But I also now know that a is 2x and b is negative 3y, so I can do a substitution. 2x to the 4th power for the first term, plus 4 2x cubed, negative 3y for the second term, plus 6 2x squared, negative 3y squared, plus, I'll see if I can stuff this in, 4 2x, negative 3y cubed, plus negative 3y to the 4th power. Alright, and again, we can do this pretty easily. We can use our calculator. 2 to the 4th is 16, so it's 16x4. And then the coefficient here is 8 times 4 times negative 3. 32 times negative 3 is negative 96, x cubed y. Then 2 squared is 4, and 9, that's 36. 36 times 6, and I'm hoping I'm doing the math right. 216x squared y squared. Then over here, again, we know we got 4 times 2 is 8, times 3 to the cubed is negative 27. So 27 times 8, 56 plus 160, so it's negative 216 xy cubed. And finally the last one, negative 3 to the 4th, which is plus 81y to the 4th. And you notice everything with an even power here worked out to be positives, but this is that binomial expansion. And this is a powerful way to do that quickly. And Pascal discovered it long ago.